All right, welcome back, seventh grade. We are going to move on today to section 7.2, which is the next section in the thermal energy unit. Just a reminder, by 3 o'clock today, you need to make sure you have submitted your Achieve Graphic Organizer on Classroom and that you have taken the 5.1 quiz. I will be grading those on Wednesday evening. All right, so to start out with 5.2, well, actually, here, let me back up. One thing I want you to do this evening, I've posted pictures of your book with what I want you to have highlighted. And as you can see, there really are only 2 pages in this section. It's pretty densely packed with information, and I don't really love the way your book goes about explaining this. So I'm going to go through a PowerPoint with you that hopefully gives a little bit more insight. And then I also have a video from Mr. Anderson from Bozeman Science that I want you to watch that also gives a little bit more insight into the processes of convection, conduction, and radiation. But in terms of your book, make sure that you have highlighted what I show you to have highlighted in the book. But like I said, it's pretty bare bones. So let's move on to my lecture. All right, so section 5.2 is all about the transfer of thermal energy. All right, and that transfer of thermal energy we know as heat. Okay, the process, and Mr. Anderson's going to talk about this in his video. The process of energy transferring from an area that is hotter to an area that is colder is called heating. And the amount of energy that is transferred in that process, the amount of energy that leaves the hotter object or area and moves into the cooler object or area, is the heat. So heating is the process, heat is the amount of energy that changes over. So heat transfers all the time. All right, we know this because if we didn't have heat transfer, nothing would ever change temperature. But as we've talked about, and some of this should sound familiar because we started to look at this with the activity that I want you to wrap up from when we were in school, and I'll get to that. Heat does not transfer randomly. It goes from an area that is hotter, an area or object that is hotter, to an area or object that is colder. It only flows in one direction. And there are 3 ways that this happens: by conduction, by convection, and by radiation. All right, as we know from the past, all matter is made up of atoms, either single ones or atoms bonded together in groups known as molecules. These atoms and molecules are always in motion. Remember, even the particles within these atoms, the electrons, when we were talking about electricity, those electrons are always in motion. If the atoms or molecules have the same mass, in general, something that is hotter is going to move faster than something that's colder. And you did see that on the simulation, on the thermal energy simulation that we started with a couple weeks ago when we were in school. And I'll get to that simulation at the end of this lecture. All right, so just to reiterate, this is what a solid looks like, right? Your atoms are rigid. They are in a fixed shape, a fixed volume. Liquid. They aren't in a fixed shape, but they do have a fixed volume, and they are not rigidly arranged. And in a gas, they're not rigid at all. There's no fixed shape. There's no fixed volume. The point of showing you these 3 phases is that within all 3 phases, the atoms and molecules are still moving. So in the solid, obviously, they're vibrating in place. In the liquid and the gas, their movement is, they're able to move a little bit more. They're able to move from place to place, or they have translational movement. Okay? All right, so that's our background info on atoms. So what is conduction? So we're going to use the example of putting a pan on a stovetop and turning on the heat. The metal pan that is sitting over the burner, the bottom of the pan, is the first part of the pan that gets hot. That metal's touching either the direct flame if you have a gas stove or the top of the surface of an electric stove. Either way, that metal is physically touching the hot surface, and the atoms in the pan's bottom will start to vibrate faster as they warm up. As they vibrate faster and they're moving more and more in place, they're starting to bump the atoms around them. And so what does that mean? So if we use this as the example, these atoms here that are right in the flame are going to start moving more because as their energy increases, the kinetic energy of them will increase. And as their kinetic energy increases, they're going to bump atoms that are next to them and transfer over some of that energy. And as you can see, this bumping into one another and this transferring of energy continues and continues and continues. And it's that exchange of kinetic energy, that transferring of energy, that is causing that object touching the flame, that conductor, to heat up. All right, so that is conduction. You have to have actual physical contact between the objects, and you have one object that is hotter transferring energy to the other object that's colder through kinetic energy, through atoms actually hitting one another. Convection is, if you think convection, think of a hot air balloon. Okay, so convection is going to occur when objects are able to flow or something that is fluid. Now that doesn't mean it has to be a liquid. It can be a liquid or a gas, but the point is the atoms in the substance have to be able to move around. They have to be able to flow. So when we're using our example of the pan on the stove, the bottom of that metal pan is getting hot. And as it gets hot, eventually the molecule or the atoms bumping into one another is going to reach the water that is sitting in the pan. And those water molecules are going to start heating up. And as they heat up, those water molecules are going to spread out because as the water warms up, it's going to expand. And that will make that portion of water less dense. So for example, here I have 9 water molecules in this amount of space, and as I heat it up, the amount of space expands, and I still have 9 water molecules. So I still have the same amount of water, they just take up more room. They're less dense. This less dense water then is going to start to rise above the more dense water that's around it. And that rising of the less dense hot water is going to carry the heat away from the flame and distribute it through the water. Meantime, the cooler water that's sitting at the top of the pan is more dense and it is going to sink to the bottom of the pan. And so it's this motion of the hotter, less dense water rising and the cooler, more dense water falling. That forms what we call a convection current. And this convection current is going to transfer heat throughout the fluid, throughout the water or the gas. And that, when Mr. Anderson talks about the hot air balloon, that's what's going on inside the hot air balloon. The air molecules that are closest to the propane, to the flame, are going to heat up and rise because they are less dense. And the more dense molecules of air are going to fall along the side of the balloon until they reach the bottom, at which point they'll get heated up by the flame. And so this goes on and on and on. So that's convection. The last one I want to talk about is radiation. And the unique thing with radiation is that radiation does not need a material to flow through. So with conduction, you had to have materials that were touching. In convection, you had to have a fluid. You had to have a liquid or a gas where particles, atoms were able to move. In radiation, radiation can go through material, but radiation can also go through vast amounts of space. So the perfect example of radiation would be the heat we feel from the sun, the energy we feel from the sun. We aren't touching the sun to feel the heat of the sun. Those heat waves are transferred through the atmosphere and we feel them. So radiation is going to be this emission or transmission of energy in the form of waves or particles. And yes, it can move through material, but it also moves through empty space. All right, here are some of the other examples of radiation we have. So you have light, you have X-rays, you have radio waves, which allow you obviously to listen to the radio, but then this infrared radiation is the heat radiation that we feel from the sun or that you feel from a fire if you're standing around a campfire. So unlike conduction and convection, radiation doesn't require a material to transfer its energy. All right, so that's the end of my PowerPoint. let's see where we're at on time. I'm currently at 9 minutes, so I got about 5 minutes left. All right, I want to quickly go over. Let me find your classroom. I've posted doodle notes. If we were in class, I would make you take these and do them, but since we aren't, I'm just posting the finished copy. I like these doodle notes because they are a good visual explanation of what we talked about. So here we have the radiation, the heat waves, okay, coming in waves, heating it up. Here we have our convection, where these molecules are moving, and we have the warmer, less dense rising and the cooler, more dense falling. And then the handle of the metal pan is showing conduction, where we have direct touch, and we're transferring that heat through direct touch. All right, so that's one doodle note I wanted to show you. And again, up at the top, it's just talking about how we're always going to move from an area of high temperature to an area of low temperature. All right. And then this just gives a little bit, few more examples. So convection goes on, like it said, through air fluids like air or water. Convection actually goes on in the mantle, and we'll get to that next year. But it's this motion in the mantle that actually causes tectonic plate movement. But again, we'll get to that next year. And here's our example of the hot air balloon, where you have hot air rising and cooler air falling. All right, conduction, right? We have the pan. We talk about how if you go to the beach and you walk on the beach, the feeling of the heat from the sand when your foot touches the sand would be an example of conduction, and that you have to have direct contact. And then radiation is going to be heat that is moving between objects that are not touching. So you have examples like the sun. You also have examples of using a campfire to roast marshmallows. That marshmallow is getting heated up without ever touching the fire. All right, so for homework tonight, I want you to do this. Let me go to classroom, close this out. Answer I didn't post yet. I'm going to post a question and answer doc that you need to turn in by Friday. And then you also will be, let me bring up your, let's get your schedule up here just so I can go over it with you. All right, here we are, 7th grade. All right, so for Thursday, for me, you're going to be doing a little lab. I'll be on tomorrow to explain that. And then you also need to make sure that you're completing the online thermal energy transfer simulation that we started prior to break. Let me see where that is. Recent. Oh, here it is. So we started this in class. I'm going to, we did the first page together. So as you can see here, I typed the answers in. I'm going to post a blank one on Google Classroom. You can either take pictures of the one that you completed in class and attach it, or you can just type your answers in. But I want to give you guys credit for having done this. Remember, we did this simulation prior to break. So I will repost it for those of you that aren't finished. And again, that's due Friday as well. All right, if you have any questions, I have office hours on Thursday at 11 a.m. You're welcome to come on and ask me any questions. Otherwise, I will be posting another lecture on Thursday. It'll be shorter, just showing you what I want you to do for the little online lab we're going to do this week. All right, I hope you guys are having a good day, and I will talk to you soon. Bye.